Okay, so this problem is going to help you if you are stuck on how to do the car collision challenge. This is not exactly like the car collision challenge. These two vehicles are traveling in the same direction. With the car collision challenge, the two cars are traveling in opposite directions. So we have a car traveling at 76 kilometers per hour and it's 780 meters behind a truck that's traveling at 66 kilometers per hour. So I'm going to start off by drawing a picture, and we want to know how long will it take the car to reach the truck. So here's the car, and we can say that its initial position, the car, is 0, and we know that it's traveling with a velocity of 76 kilometers per hour. Okay, and then it says the car is behind the truck. So let's put the truck right here. And it tells us that the car is 780 meters behind the truck and that the truck is traveling with the velocity of 66 kilometers per hour. Now, really these are speeds because they don't include direction, but we'll just assume right now to the right. Now, here's an issue. Notice 780 meters is in terms of meters, and both of our speeds are in kilometers per hour. So we do need to convert that 780 meters to kilometers. So 780 meters, we're going to use dimensional analysis. We want to get rid of meters, go to kilometers, and we know that there are 1,000 meters, or 10 to the 3 meters in 1 kilometer. So we can either move the decimal 3 places to the left, or we can divide by 1,000. It's all the same thing. So 0.780 kilometers. I'm going to actually change this to 0.780 kilometers. Now, with that being said, if the initial position of the car is 0, then that means that the initial position for the truck is the 0.780 kilometer position. Okay, so what else? We know it says how long will it take, so we're looking for time, the car to reach the truck. So eventually, the car and the truck are going to reach each other, which means that the final position for the car is equal to the final position for the truck. How long will it take the car to reach the truck? Well, if time starts at 0, that means that the time for the car to get from that initial position of 0 to that final position, that's the time for the car, is equal to the time for the truck to get from its initial position, which is the 0.780 kilometer mark, to its final position. So this is also the same. So notice we have two unknowns, but we know that the time for the car and the truck are the same, and we know that the final position of the car and the truck are the same. So we're talking about like an average velocity. So let's think equations. We know that the average velocity is the final position minus the initial position divided by the change in time, the rate at which that position changes. So in this case, I am going to make two equations, one for the car, one for the truck. And I'm going to solve for the final position. So the final position is going to be the average velocity times the change in time plus the initial position. Okay? That's going to be the final position. We're going to do that for the car and for the truck. So for the car here, we have the final positions, which we don't know. We have 76 kilometers per hour. We have this delta t, which we don't know, plus the initial position, which for the car is just 0, so we can just kind of forget about that. Now for the truck here, we don't know the final position, okay, and that's going to equal the velocity, which is 66 kilometers per hour, times delta t, and then plus 0.780 kilometers. Okay, So we have our two equations. What do I do now? Well, we know that, again, the final position is the same for both. So could we plug this final position in here for here and then solve for delta t? So if we do that, that's going to be 76 kilometers per hour times delta t, system of equations, equals 66 kilometers per hour times delta t plus 0.780 kilometers. From here, we can now solve for delta t. So I'm going to subtract both sides by negative 66 kilometers per hour times delta t. All right, and so that's going to give us 10 kilometers per hour times delta t equals 0.780 kilometers. I'm solving for time, so I'm not going to divide both sides by 10 kilometers per hour. And so my time for the car and the truck to meet would be 0.078, and then again here, kilometers divided by kilometers per hour. We flip and multiply, and so we're left with hours. Now let's think about sig figs. So technically this 0 right here is significant, and so we should have 2 sig figs.